everyone. This video would focus on how to solve word problems involving direct variation. Before we go further, please feel free to check out the description below for the link of the other series of topics related to direct variation. Before we go over this example right here, let's have a review on the definition and real-life examples of direct variation. We remember that, by definition, direct variation is a type of proportionality wherein one quantity directly varies with respect to a change in another quantity. To better understand this, let's look at variable A and variable B. For a direct variation, if variable A increases, variable B will also increase. Now, please notice the direction of the arrow. Both of them are increasing. On the other hand, if variable A decreases, then variable B would also decrease. Again, please notice the direction of the arrow. Both of them are going down. Again, please notice that for a direct variation, both variables have to increase or both variables have to decrease. So whenever we see this type of relationship where both variables increase or decrease, we can go ahead and say that A varies directly as B, or we can also state this as A varies proportionally as B, or A is directly proportional to B. Now let's take a look at some real-life examples of direct variation. Okay, the number of hours you work and the amount on your paycheck are directly proportional to each other, which means that if you work more hours, then it means that you get more money. On the other hand, if you work less hour, then it means that you get less on your paycheck. So again, the number of hours you work is directly proportional to the amount of your paycheck. Now let's take another example. The speed of a car and the distance traveled in a certain amount of time are directly proportional to each other, which means that if a car travels faster, then it can travel more distance. It can cover more distance at a given certain time. On the other hand, if a car travels slower speed, then it can cover less distance. This tells us that the speed of a car is directly proportional to the distance it traveled at a certain amount of time. Okay, going back to the example right here, y varies directly as x. If x is equal to 3, then y equals 21. So from this first statement, it's mentioned that y varies directly as x. This tells us that since it is a direct variation, we can go ahead and say that the general equation for direct variation is y equals kx, because again it says it varies directly. And so we can go ahead and solve for letter A. So I'm going to show the work on the bottom right here. So that is again y equals kx. We are supposed to write the direct variation equation for this given data that we have here. Our x is 3 and our y is 21. So what are we going to do is we plug in the 21 into the y, because that's what it says, y. So 21 equals k and our x is 3. So we are going to solve for k. So we can do that by dividing both sides by 3. We divide this by 3 so we can cross the 3 out. So this gives us 21 divided by 3 is 7, and that is equal to k, or k is equal to 7. So this is our value of k. Now we are supposed to again determine or write the direct variation equation of the given data. So we have a k, so we go ahead and plug it back into the equation. Instead of writing k, we're gonna write 7. So this comes out y equals 7x. So this is the answer to the first question. Write the direct variation equation of the given data. So y equals 7x. For letter B, we are supposed to determine the value of x when y is 35. So what are we going to do for letter B is that we use the equation that we've gotten from part A or question A, which is y equals 7x. Again, we're solving for B. Find x when y is 35. So our y is 35, and then we got a 7x. We are supposed to solve for x. We can do that by dividing 7 to both sides. Divide this by 7, so we can cross the 7 out. We are left with x is equal to 5. So this is our answer to question letter B. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're going to solve for letter A. And then in the statement here, it says that y varies directly with x. This tells us that it is a direct variation. And again, remember the general equation for direct variation is y equals kx. So we are supposed to write the direct variation equation of the given data. So we have y is negative 20 and x is equal to 4. So I write negative 20 equals k times the x is 4. So we're going to solve for k. So we can do that by dividing both sides by 4, dividing by 4. So we are left with k is equal to negative 5. So this is our value for k, and we plug this k back into the equation. And so the equation that would work for this problem would be y equals negative 5x. So this is the equation for this direct variation. Now let's go on to letter B. So in letter B, we are supposed to determine the value of y when x is 6. So we're going to use this equation, y equals negative 5x, but we plug in the 6 to the x and we solve for the y. And this is how it's going to look like. So our value for y is negative 30 when x is 6. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. Okay, in this problem, it says that a person's salary is directly proportional to the number of hours worked. Godi pays $84 for 8 hours of work. Write an equation for the relationship between the salary and the hours of work and find the salary for 40 hours of work. So we go ahead and assign variables to each of the quantities that are involved. Others would prefer to use X and Y. That is totally fine. But then let's use other letters in the alphabet. So we start with the salary first. So I'm just going to go ahead and label this as capital letter S for the salary. And it's directly proportional to the number of hours. And that is H. So again, it says here that they are directly proportional. Now we remember that for a direct proportion, our general equation is y equals kx. So in this case right here, our salary, we write the salary first. So S equals kh. So this will be our equation. So again, you can use y equals kx. You can use other letters in the alphabet. That should be fine. But in this case right here, our S stands for the salary and our H stands for the hour. Now it says here that the salary or the paycheck was has an amount of $84 for working 8 hours. So then we can go ahead and say that the salary here is 84 for working 8 hours. So this is the equation. So we're going to solve for k. We can do that by dividing both sides by 8, dividing this by 8, so that we can go ahead and cross this out. 84 divided by 8, and that gives us k is equal to 10.5. This is in dollars, and that is per hour. Or you can just keep it as 10.5. That should be fine. So then we can go ahead and say that our equation, we go back to the original equation that we got. Let's just use this. We can go ahead and rewrite this as S equals 10.5 H. Or if you would want to use the y and x variable, that would be y equals 10.5x. Any of these should be correct. So we can use X and Y, or you can assign any letter in the alphabet. In this case right here, I write S for salary and H for hours. Now, in the second problem, we are supposed to determine the salary for working 40 hours. So for letter B, I'm just going to go ahead and show the work down here. So I'm going to use this equation, S equals 10.5H. Since we say that in this problem, it was 40 hours, so I plug in 40 here and we find the salary. So S is equal to 10.5 times 40 hours. If we multiply using the calculator, that should give us S is equal to $420. So Godi is going to get paid $420 for working 40 hours. So this is the answer to letter B. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's go over the problem here. Gwen received 55.35 in interest on a 1,230 deposit in her bank account. If the interest varies directly with the amount deposited, write the equation of the relationship between the interest and the amount deposited. And how much would Gwen receive for the same amount of time if she had $2,000 in her account? So we're going to assign variables here. Again, we can use X and Y, but I'm going to use different letters here. Let's use I for the interest, and then we're going to use the deposit as letter D. Since we say that the interest is directly proportional to the amount deposited, we remember that direct proportion means that the general equation is y equals kx. In this case right here, we start with the interest I equals k and then the deposit D. So this is the equation. Again, you can use X and Y, you can use any letter in the alphabet, that should be fine. So then we go ahead and use these values that we have here to determine the K. So our interest is 55.35 and then the K is missing. The deposit for this amount was actually 1,230. So then we solve for K by dividing both sides by 1,230. Divide this by 1,230. We can cross this out. Our K value, if we use calculator for this would give us 0.045. So then we can go ahead and plug this K back into the equation. So if you use the X and Y, you can have Y equals 0.045x. Or if you want to use the other letters that we assigned, I for interest and D for deposit, that would be interest is equal to 0.045 times the deposit. So these two are the equations. So any of these would work. So this would be the equation to solve for letter B. So in letter B, how much would Gwen receive if for the same amount of time if she had deposited $2,000. So let's use this one right here. So that is interest is equal to 0.045 times the deposit. So that would be, we wanted to determine the interest. So that would be equal to 0.045, that's the I, and then the deposit is 2,000. So I write 2,000 right there. And so using the calculator, multiplying those two, this gives us $90. So the interest that she would have gotten if she had deposited 2,000 instead of 1,230 would be $90 instead of $55.35. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!